Good afternoon and good morning to those who are in Europe. It's a wonderful day in Japan and a very warm welcome to all of you in the Aspire and Horizon Europe Momentum with Japan's Association webinar. I'm Judith Erika Magyar, country representative of Eurostat Japan. And in this webinar, we're going to highlight successful collaborative projects between Aspire in Japan and Horizon Europe in the European Union. The projects are introduced by the Japanese and European contributors who do not only provide best practice examples about international research cooperation, but will also answer questions live. We will also hear from colleagues in Japan from JST and the delegation of the European Union to Japan. So let's start the webinar with the first speaker, and let me give the floor to Yuta Kawashima, who is Chief at the Department of International Affairs at the Japan Science and Technology Agency. He's going to talk about the Aspire program. Yuta, the floor is yours.
All right. Thank you. Thank you very much, Judith, for your kind introduction. Good afternoon for those who are in Japan, and good morning, people in Europe. My name is Yuta Kawashima, Department of International Affairs of Japan Science and Technology Agency. I am here to briefly explain JST's Aspire program. I'm very glad and honored to explain our program in front of such many people, both in Japan and Europe, especially in the context of Japan-Europe Research Cooperation. So I am going to explain the overview of JST Aspire first. Before going into the program detail, I'd like to show the key messages first. So as you see the diagram in the bottom half, Aspire, JST's Aspire, focusing on talent mobility, and Horizon Europe, focusing on joint research, are to complementarily strengthen Japan-Europe research cooperation. That's the first point. And secondly, of course, in the context of Japan's upcoming association to Horizon Europe, it is expected to broaden collaborative opportunities. So you see the circle in orange that I would expand the breadth of the circle. That's the image of the complementarity between Aspire and Horizon Europe in the context of association. So first briefly about the JST. JST is a national research and development agency that plays a central role in the National Science, Technology, and Innovation Basic Plan. So we started the organization since 1996, and our budget for the last fiscal year was 261 billion Japanese yen, equivalent to 1.4 billion euro. And this fiscal year, the budget size is 20% more. So we are growing our activities. So as to the administrative structure, JST is one of the 3 funding agencies supervised by Ministry of Education, Culture, Sports, Science, and Technology, shortly MEXT. And among the funding agencies in Japan, JST is placed in this diagram. So JST is categorized as top-down funding agency, mission-oriented. And we cover from the basic research to the beginning stage of the applied research. And our main activities are 4 pillars. The first, research funding, and the other 3 are public engagement, information platform database services, and our R&D strategic planning. And as you see the graph, research funding takes more than 80% of our budget. So we have a various kind of research funding programs, and we largely there are 3 pillars: the strategic basic research, industry academia collaboration, and technology transfer. and international collaboration, which I will talk about. So within the 4 international collaborative programs, each program has each objectives and partners and scheme. And now I'm going to talk about Aspire. So the program overview of Aspire. Aspire stands for Adopting Sustainable Partnerships for Innovation, Innovative Research Ecosystem. So Aspire is an international joint research program which is designed to build a network among the world's top research talent, promote Japan's participation in the international top research community, and to nurture, mobilize future research leaders. So that the uniqueness of this program is to focus on international talent mobility and circulation through international joint research. So how it works, this is the kind of rough diagram of the structure. So first of all, top researchers from Japan team and partner team make a joint research. And under the joint research project, both teams promote mobility among all equal researchers. So the major requirements for proposal, this is the unique point of Aspire. So the first point is about outgoing and invited researcher. We request each proposal that all inquiry researchers are required to travel to the partner countries to conduct research activities there for about 1 year. And the second point is use of the budget. 70% of the total direct expenses are expected to be used for the purpose of promoting talent mobility and circulation activities. So by making these requirements, Aspire as a program is to design and encourage researchers to focus on the mobility. So the program has 2 call types. The one that on the right side is a joint call. It's a normal co-fund scheme, so to speak. And the other is a call for Japan-based researchers, which is relatively unique. So the fund is only going to Japan-based researchers, provided that the partner countries, the researchers in the partner countries have already been funded. So within the call for Japan-based researchers, we have 2 types. The one is for top scientists, and the other is for rising scientists. And research fields and partner countries are designated by the government. We have 7 fields: AI information and intelligent robotics, biotech, energy, quantum, semicon, and networks and telecommunication. And partner countries are on this diagram, and I put the red color on the European countries. And one note is that we included EU. So any EU member states could be eligible if they are funded by the EU. That's the condition. And other EU countries named in this diagram is without any condition are eligible. So support scale for Japan side is for top scientists around 500 million Japanese yen, equal to 2.8 million euro for 5 years, whereas rising scientists are around 90 million Japanese yen for 3 years, equivalent to 500,000 euros. So the results of the call for Japan-based researchers. So we started the first call in 2023, and we have conducted 3 calls, and this is the result. we have funded in total 113 projects so far. And out of the 113, 86 collaborate with Europe. So that's a significant number. More than 3/4 of the projects are collaborating with European countries. And when it comes to joint calls, we have conducted in total 6 calls with United States, UK, Germany, and Netherlands. And all 70 projects collaborate with Europe, including the one with United States, because the United States one is a multilateral call, including UK and Finland. And 2026 call has just started in mid-March. And the application deadline is 19th of May, 2026. So I would highly recommend researchers, both in Japan and Europe, to consider applying to the 2026 call. So any questions for anyone residing in Europe? We have overseas office in Paris. So the picture, Mr. Yamada is the director of Paris office. He is anytime available for your questions and comments. So key messages, again, I'm going back to the first slide. So as I explained, Aspire, focusing on talent mobility, and many projects are now in collaboration with Europe. So so it's a complementary role along with joint Horizon Europe, focusing on joint research. And the association of Japan further broaden the collaborative opportunities for Japan, so that, for example, Aspire projects in the future, they're gonna think about applying to Horizon Europe with the chance of the association, and vice versa could happen. The Japan-Europe projects in Horizon Europe, when they think about accelerating the mobility action, then they can think about Aspire application, so that the positive cycle could be created. So thank you for your kind attention.
Thank you for the very detailed explanation. And let me just say that this webinar would have not been possible without the very proactive and helpful collaboration by Yuta Kawashima and JST colleagues. So all my gratitude. It is my pleasure to welcome Tom Kuczynski, who is the Science and Technology Advisor at the Science, Innovation and Digital Policies section at the delegation of the European Union to Tokyo.
Once again, thank you very much for inviting us to this seminar. I'm very looking forward to learning myself about successful collaboration between Aspire projects and projects under Horizon Europe. Before that, it is my pleasure to deliver short remarks on Horizon Europe and Japan's association to Pillar 2 of Horizon Europe. Probably many of you know already that Horizon Europe is the EU's research innovation funding program for 2021-27, with the overall budget of almost 94 billion euro. The EU Framework Program is the most open research funding program globally, with a history of over 40 years. We have right now the 9th edition of the Framework Program. It was set to achieve the EU's research and innovation priorities, such as to fuel EU scientific and technological excellence, to tackle policy priorities, especially green and digital transitions and SDGs, to boost Europe's innovation uptake, competitiveness, and jobs, and to bring together the world's best talent, expertise, and resources. Most of the funding is allocated based on competitive calls for proposals set out in so-called work programs. The research generated by Horizon Europe has a very high impact factor and very high citations. And an important feature of the program is that a large portion of projects generated by the program in overall are consortium-based. And so typically in Pillar 2, which we'll talk about, we have on average 8 to 10 entities from 5, 7, 8 countries. So there are really multilateral large projects. The work programs cover the following components of Horizon Europe, divided just in short into 3 pillars. In Pillar 1, on the left, we have training, mobility, and mono-beneficiary schemes under Marie Skłodowska-Curie actions, European Research Council, as well as actions to support research infrastructure. These are mostly bottom-up schemes. Then in Pillar 2, focusing on collaborative research in six areas, we call them clusters. Here, large research consortia compete for funding under top-down calls for proposals, a little bit like Aspire, with a major difference, however, of being funded to carry out research rather than mobility. And it is to achieve research results outlined in calls for proposals. And finally, we have Pillar 3. It is Innovative Europe, where the key part is the European Innovation Council, to support game-changing innovations throughout the life cycle, from early stage research to proof of concept, technology transfer, and the financing and scale up of startups and SMEs. Now on association, several years ago, EU and Japan started exploratory talks on association of Japan to Horizon Europe. This would allow research entities in Japan to be automatically funded if they participate in research consortia selected for funding under calls for proposals in Pillar 2. Before association, in Pillar 2, entities in successful proposals from Japan, they had to secure their own funding. Now it is no longer necessary. That's why this association revolutionizes the way we collaborate. And also association is the closest form of collaboration under Horizon Europe between EU and countries which are non-EU countries. The official negotiations were launched in November 2024 and were successfully concluded in December last year. The most important message today in my presentation is that although the adoption procedure is still ongoing, the signing of the association agreement is expected to take place in summer. The transitional arrangement allows Japanese entities to benefit from association, basically from the beginning of this year, meaning also now, under virtually all calls for proposals in Pillar 2 for years 2026 and also in 27. So it is really, once again, the right time to get involved. There is no reason to wait for anything. Once again, Association of Japan to Horizon Europe enables Japanese entities to receive funding directly from the program. Japanese entities can be coordinators of the projects. Association enables Japanese entities to participate in most of calls for proposals in Pillar 2, which are not open to countries not associated to Horizon Europe. So there's a clear benefit for Japan to be associated. Importantly, association gives the government of Japan the observer status in so-called program committees, where the program and forthcoming calls of proposals are discussed and agreed. So it simply gives Japan an opportunity to reflect topics important for Japan in the work programs. Now for the current work program. Horizon Europe, as well as its predecessors, are divided into so-called work programs. They run for 2 to 3 years. Horizon Europe is divided into 3 work programs, and we are now in the final one, covering 2026-27. So basically, all calls for proposals are already published. Many of them, they are open. The whole work program for these 2 years has a total budget of 14 billion euro. Work program 26-27 introduces horizontal calls for tackling key policy priorities in a more consistent and multidisciplinary way, in particular in realizing the Clean Industrial Deal and AI in science. Current work program stresses knowledge valorization to increase impact in society and policy. And it also introduces Choose Europe for Science initiative, which aims to promote research careers in Europe. All information on Horizon Europe, all calls for proposals, can be found on EU funding and tenders portal. This includes work program, all call texts, eligibility, deadlines, partner search, and so on. Those interested in the past and recent projects may refer to the Cordis database with basically archives of dozens of thousands of projects resulted from the previous and the current edition of the program, and also to a very useful tool called Horizon Europe Dashboard. There you in Cordis and also in Dashboard, you can you can find the research results by topic, information on coordinators, compositions of projects, and many other useful information, especially to those who are starting from the scratch collaboration. Regarding the next edition of the framework program, Horizon Europe 2028-2034, the proposal was adopted already in July last year. It is a proposal for a strong, self-standing program, fully aligned with EU's key priorities to strengthen EU competitiveness. The proposal budget is 175 billion euro, so it is unprecedented budget. The new framework program will introduce further simplification, synergies with European Competitiveness Fund, and will support dual use. Once again, maybe I'll stop sharing here. Association is the game changer for the EU-Japan research collaboration. It is indeed right now it's the right time to get involved. Please look into EU funding and tenders portal to find calls of your interest. Importantly, speak with your partners in Europe or in Japan and join calls of your choice. If you have any questions, of course, there will be a Q&A session, but at a later stage, you can also contact either the delegation or national contact point for Horizon Europe in Japan, which was established by the government of Japan and supported by the government of Japan. Thank you very much.
Thank you for the very detailed and extensive presentation about Horizon Europe and indeed Japan's momentum of Association to Pillar 2. It's a great step for both parties. And I think the number of participants in our webinar attests to the very voluminous interest in this particular collaboration. Thank you again. And I would like to invite the first project speaker, Group Leader, Professor Takashi Tsuchiya at the Research Center for Materials, Nanoarchitectonics, National Institute for Materials Science, to introduce the project titled Building a Next Generation International Network for the Creation of Ultra-High Performance Electronics-Based Neuromorphic Systems. Professor, the floor is yours.
Okay, thank you very much for your kind introduction. Dr. Tsuchiya from National Institute for Material Science, and I'm a Japan PI for the Aspire project for the rising scientist. And today, I'd like to talk about our Aspire project, which just launched from the last December. And yeah, and, my talk will be with my Professor Juan Biscot. He's a Europe PI. And yeah, actually, this is a title of my talk, but actually, Judith and Yuta Kawashima, they request me that I should not to focus on the very detail of our research itself, but we need to talk about overview and the benefits of our Aspire project, and also they requested me that I to talk about the story behind our application to the project. So I will talk about this in the for sometimes, and then after that, maybe Juan he will add some detailed explanation about our project on the theoretical aspect. Okay. By the way, my talk, my research results reported here was achieved by my collaborator in my group members and also the other members. And also my work was supported by the Aspire project also, and also JST Presto. Okay. Our work is backgrounded by the very strong demand for the development of the low power AIs. As all of you know, all of you already recognize that AI is quite powerful these days, but at the same time, it is quite energy hungry. So now our society is trying to switch to cloud AI to edge AI. In the edge AI system, we have so many sensors, and these informations detected by the sensors could be processed at the near the base sensors. So we need to develop AI hardwares which can operate with low power consumption. These are the examples of the resource constraint edge AI devices. Yes. So for this such kind of the physical implementation of the such, AI or such devices, we need to develop the low power consumption AI hardwares. So how we can do this? One of the idea can be comes from the theoretical or works regarding the unconventional computing. That is reservoir computing. Here I'm showing the schematic of the reservoir computing. This is consisted of basically three layers: input layers and the output layer, which is similar to the deep learning, but the different, significant difference from the such deep learning is the reservoir layer, which is consisted of small numbers of nodes and edges. So the feature is significantly fewer training parameters in this schemas. And also, due to the very small number of the training parameters, we can get high speed in training and processing. But also, for the material scientists, it is very interesting point is that such reservoir computing capability can be reproduced by utilizing the nonlinear response of the material or the physical devices. So for example, we have some physical devices with some properties with nonlinearity. This is a property relationship between the input and output. And short-term memory features the capability to store the information in size, and also the high dimensionality. This is the kind of a diversity of the output from the material or devices. If we can get such kind of the suitable material or devices, we can perform the reservoir computing by using the physical device. So recently, many researchers are seeking for the suitable material or devices. But yeah, here are the examples of the such material devices. Actually, there are various cases, and actually they are quite successful to implement the physical reservoir computing functions. But in some cases, performance is good, but they are getting a very huge volume. And the other cases, they get a very small volume, so it is quite advantageous for the integration, but the performance is not so good. So now we are seeking for the very suitable material system for implementing such physical reservoir computing. And in that sense, the iontronics is a quite promising research field. It is defined as ion-controlled electronics. Here is an illustration of the iontronics approach. As you can see here, the iontronics, it is basically based on the interface phenomena with the semiconductor or the insulator and the electrolytes or the ion conductors. In the vicinity of the interface, we have the very strong electric fields and high density charge accumulation. So we get a very high electrical capacity reaching the several tenth microfarads. And also, due to the such high electric double capacities, the charge density can be reached very high. So based on such great function of the interface, so far, iontronics has been utilized for the exploring the novel electronic functions. Some examples are shown here. It has been utilized for the exploring the novel superconductivity or the magnetic materials or the metal insulator transition. As I already mentioned, due to the very high EDL capacity, it can be operated in the very low voltage. So it is very advantageous for reducing the power consumption if we apply this to electronics. But also such high density charge accumulation, it is also advantageous for access to the various untouched electronics functions. And also, as you can see here, this occurs in the very, very thin region. So it is quite advantageous to develop nanoscale devices. So based on this idea, we have been working on the development of a new physical reservoir computing framework. That is ion gating reservoirs. Here, I'm showing the scheme of our reservoir device, which is basically taking the similar structure of the iontronic transistors, consisting of ion conductors and the semiconductors. By input some information from the gate electrodes, we can modulate the condition of the interface. So we can get such fluctuation of the chemical state by using the drain current through these electrodes. So we can get the dynamic behavior or the nonlinear transformation from the input to output by using very simple structures. And here I'm showing the performance comparison with the ion gating reservoir and with other physical reservoir systems. As you can see here, such iontronics-based physical reservoir shows a very good performance, and also it achieves a very small volumes. So this performance was achieved by the lithium-ion conducting solid electrolytes with diamond EDL transistors. So this can be a very good example of the iontronics showing the very good and promising performance for the reservoir computing. And one example are shown here. We utilized our ion gating reservoir for the pre-processing of the sensors. In this case, we used the electrode sensor. This is a kind of a vibration sensors, and actually this is attached to on the surface of the throat, and you can detect the vibration of the throat during you say something. And this is an example of the signals detected by these sensors. And in this case, we input such vibration signals to our ion gating reservoirs. And we try to classify what he's saying without using the audio data. Here, I'm showing the comparison with the performance. First, these cases, we just check the performance of this sensor alone. In this case, the classification accuracy of this sensor is just about 10%. This is almost similar to the random selection. This means that this sensor alone cannot classify what he's saying. But with our ion genetic reservoir, we can successfully classify what he's saying with these sensor signals. So this is the very promising example of the example for that to show that such ion tronics-based neuromorphic computing is quite promising for the combination with the sensors. So based on such successful results, we launched the Aspire project regarding the next generation development of the ion tronics-based neuromorphic computing. From the Japan side, I and Shinpei Ono from Tokyo University and Professor Nakano in Shibara Tech, and also in European side, Professor Barov from Germany, and Professor Diaz in France, and Professor Juan Biscot here in Spain, and also the Professor Rosera from Italy. The project is it's aimed at development of the pioneering work regarding neuromorphic computing based on the ion tronics, but also it is also aimed at fostering the young researchers to sustain this network. And this project is basically consisting of the three hierarchical structures. On the bottom part, we develop the novel material or the method to for the transducer of the information to the different forms of the information by using the ion tronics phenomena. And then the second part, we will dig into the mechanism of the ion tronics and also the theoretical parts of the such neuromorphic or the unconventional computing. And then we also combine these things to make a brand new neuromorphic technologies on the basis of the ion tronics. Okay, and the remaining times, I'd like to talk about our story behind our application to Aspires. Actually, it was 2 years ago. I organized an international workshop on the ion tronics by support of the JST Pressed grant in the Patisina, Nagano, Japan. And actually, for this workshop, actually, I invited many researchers from all over the world. And actually, in this workshop, we discussed various kinds of topics, the optoelectrics, spintronics, and the superconductivity, and any kinds of very interesting topic. And they all with ion tronics. And during this workshop, we recognize that such ion tronics research is now fragmented in all over the world, and also the ion tronics technology has a huge potential for the such next generation development. And then another very important aspect is a meeting with Professor Huang. He will talk about it later. Actually, on the day of my leaving for London, the conference, it was maybe also 2 years ago. Yes, 2 years ago. Yeah, he actually we never met each other, but he suddenly gave me an email to suggest the meeting at London. Actually, I'm just leaving for London, so I just I respond yes, and we met each other in London and talk about such possibility of the novel neuromorphic computing, the unconventional computing on the basis of the ion tronics. And in particular, I'm developing a transistor. So he suggested a lot about the new direction of the neuromorphic computing with the ion tronic transistors. And also, he suggested to me that I should organize such an international conference to make a network with different ion tronics or the neuromorphic computing researchers. So last year, I organized the Neuronics conference in Tsukuba. And actually, in this during the organizing this conference, I came across many outstanding European researchers regarding the ion tronics and also neuromorphic computing. So based on these experiences, we had an idea that bringing together such a diverse and excellent researchers to form such a joint research network for the neuromorphic computing, in particularly with iontronics. So that is why we applied together to the Aspire project. And after we just launched our Aspire project, we already held the kickoff meeting in Germany. Yes, in the last February. Yes, yes. He's a Germany PI, Professor Barov, and in his research center, we had workshop with PIs, and also young postdoc researchers also had a oral presentation, and also young researcher like students, they also had a poster presentation to know each other and request the important suggestion from the European researchers. So during this workshop, we had a very good we made a friendship together, and also yes, so we had a very good time, and so now we're discussing the brain circulation in this project. Yes, and here I'm showing the brain circulation plan in this project. This is a tentative one, but we had already planned to send many young Japanese students or researchers to the Europe, and also we will accept the many senior researchers, the postdoc researchers, and students from Europe. Yes, so from these brain circulations, we will receive the strong benefit. That is, yes, the first thing is a tight collaboration with the high-level researchers from the Europe, but not it is not the only things. We also get the benefit from the fostering the young researchers in the state-of-the-art research environment in Europe. And also, they will have great opportunities for to develop their career in Europe after getting the PhD or after spending the PhD in postdoc stage in Japan. Okay, so let me summarize my sites. Our Aspire project is designed to make a strong collaboration with Japan and the European researchers, and this is toward the unconventional, the neuromorphic computing on the basis of based on the iontronics phenomena, and these are quite promising for achieving the low power, low computational loads on the high accuracy or the fast processing on the basis of the iontronics phenomena and the characteristics. Okay, thank you. And in the time remaining, Juan will provide a very detailed talk about our project, in particular the theoretical aspect. Thank you.
Thank you very much for introducing the project. It is a very exciting work, and we can see that there have been multiple partners involved. And one of them who is going to talk about the project in more detail is Juan Bisquet, distinguished researcher at the Instituto de Tecnología Química at CSIS, Universitat Politécnica de Valencia. The title of his presentation is Synapses and Neurons for Unconventional Computation.
Thank you for the presentation. I will follow up from Suchiya Sensei. And first, this is the group in Valencia. The group is based on ERC Advanced Grant, and it's now focused on functional ionic electronic devices for neuromorphic and unconventional computing. And I want to talk of one specific topic that is essential for the advance of this brain-like computation, in which we have, as already explained, conventional computing, which is very fast but energy consuming, and this is a major problem in the future. And we have another reference of computing, which is the brain, with billions of neurons and synapses, and doing very complex computation on real time based on perception, and it uses very low power. So this is a key thing that we want to reproduce. So instead of the traditional computation where we move from memory to processor, and this has energy losses because of the transport of electrons. We want to reproduce with, like, take the brain as a reference where memory and processing is combined in one place. So key to all this thinking of the brain, as everybody knows, is the neuron. Well, there are billions of neurons in the brain and in the nervous system, and they are connected by synapses, and they transmit some uh, potential signals. And this is a fully ionic object, so there is really not electronics here, but we want to understand how it works because with apparently simple electrochemical signals, it makes all the process of thinking and perception, etc. So what a neuron is doing is receiving information from other neurons in terms of temporal spikes of voltage, which is called spiking. And then this come filtered by some synapses, and they might then combine. So the neuron makes an integration of the received information and sends another action potential. So this is going to form the basis of a neural network that is the process of thinking. Okay. So how is working this spiking? The neuron has some voltage gate ion channels for especially for sodium and potassium ions, and the difference between inside and outside the neuron is the relevant electrochemical properties of voltage, and this voltage spike can be activated and then it's repeated. So spiking is repeated in different patterns that convey information, not just by 0 and 1, but also by the temporal spacing of the information. So in order to reproduce the function of the neuron for making neuron-like computation, uh, we want to do oscillators. Because the property of the neuron is that it is spiking, it's like an oscillator, but it's oscillating without a periodic input. It's oscillating under a constant input. So this is a special form of oscillator that is based on an internal instability. And we can reproduce this with electronic ionic elements, like this model where there is a capacitor, a resistor, and a nonlinear element. And with this structure, we can also make spiking, and this is the basis for neuron-like computation. Okay, so then what do you need to have these oscillations? So we need a model with 2 degrees of freedom. One is the voltage and another is an internal memory element, which is like a memristor. And a second important quantity is that this element has to have a negative resistance or negative differential resistance, which creates the instability in which the system goes into a limit cycle, which is the oscillation. So this is one example that we have published recently in a physical review applied using a thyristor and the parallel capacitor, and then we can have this type of curve where in the region of negative resistance it is spiking, and we can control this system and apply nonlinear dynamical theories of mathematics and know in which region of the external parameters, like the applied current or the capacitor, the system is going to spike. So, for example, we can determine the domains where of applied voltage where of a valid current where it's going to spike or when it's going to oscillate. So the experiment, I repeat, the experimental results are here, and you can see that we can control very well the oscillations of this model, which is one type of oscillator, and there are many. And then it's what we are looking for is robust oscillator that can mate in very large quantities that are small, and this is one aspect of the computation. Okay. Then from this we can go to coupled oscillators, because the neurons operate by coupling, as I said before. They operate like in series, they retroact. And then we can couple two oscillators. And coupling oscillators, we can have very interesting dynamics where the oscillators can go in phase or out of phase according to the intensity of the coupling. And with that, we can do networks that operate not like neural networks, like general oscillating networks, where fast locking of some elements and other not will give the solution to problems. So this is an alternative to computation. So here I finish with acknowledgement to all the cooperators, and I want to mention that I just showed one element of the brain-like computation, which has extraordinary complexity, which is the neuron. And Tsuchiya Sensei showed other possibilities like the reservoir computing. So there are an enormous variety of activities. So this is a rapidly evolving field to a major challenge, which is find new ways of computation and creating and managing intelligence. So I think this project is extremely useful because each type of researcher has one specialty, but nobody can know all these aspects, all the material. It's too diverse and too big. And I think that interacting with major experts, especially with Japan, which has a different research approach traditionally from Europe, which is perhaps more focused on technology, and then we can have a great interaction and provide enormous progress. So we are very happy to be in this project, and we think it's a great initiative. Thank you.
Thank you very much for your contribution and introducing another aspect of the project. I think there are some questions in the Q&A box that your project participants might like to answer later during the Q&A. We are going to continue with the second project, and this will be introduced by Professor Yoshio Mita at the Graduate School of Engineering and University of Tokyo. Project title is Japan EU-US Integrated MEMS Network for Edge Semiconductors, providing high functionalities and revolutionary computing principles.
So I'm a director of Nanosystem Integration Center, which is a center of the Graduate School of Engineering, the University of Tokyo. I'm also a full professor of the Electrical Engineering and Information Systems, as well as System Design Lab, VDEC. And also I'm a host professor of Laboratory for Integrated Micromechatronic Systems, LIMS, CNRS Laboratory in Japan. So we pursue LSI edge devices. Official project title was introduced by Judith, so very long. So I decided myself to redefine ourselves. We call ourselves multidisciplinary and multinational open nanotechnology device development for intelligent and integrated advanced LSI. So if we read the from top to bottom, like Japanese do, this is mondial. And some of you may know that mondial is in French word worldwide. So this is a worldwide project. Yes. So the target is large-scale integrated edge devices. Edge means that like smartphone. So we are very close to the users. But also I teach since very long time as an electro information system, including sensors, processors, and actuators. Yes. So what is the edge device? So in my understanding, so this is a physical world, and the physical world so works with physics, but the informatics needs to some data or some numbers. If you know some, you can measure and express it in number, you know something about it. So we clearly need some conversion device. That is what we call input devices, or in other words, sensors. So information processing can be done in many manners, maybe including ionotronics, maybe including MEMS, or those kind of things, micro electromechanical systems. So many alternatives are now very hot in research area. But anyhow, the answer is made, hey, I would like to do something. So we need to output or reconvert that number into the physical world. That is called output device or actuators. So we cover sensors, processors, and actuators. Indeed, for a quarter century, yes, I'm given the lecture to the undergraduate students of the University of Tokyo, EEIC, Information and Communication Department students, undergraduate, since 2001. I only ask them, please realize your dream, so your system, and demonstrate. So this is some kind of group photo, including Professor Kawahara and myself. It was a very nice flaming left hands. Yes, this is electronics. So was their dreamed device. Let me show you some of the example. Shiro and Ogawa in 2013, they realized a system tricky. That is actually a group reconfigurable keyboard, actually. So ASDW, some of you may realize that this is a gaming keyboard. So I only need ASDW, I don't need a full keyboard. So he made some kind of reconfigurable keyboard. Second one, Kumeri Akaki, who was an international student, who made a LED glass. As you know that, so electronicians are so shy, yes, like me. So they probably do not want to see in their eyes. So instead, the LED displays, so array of the LED can say hello instead of you. So it was very nice, eye contact machine. Or the students in Japan live in a very miserable, I'm sorry. So it was my case, by the way, the very cheap apartment. So in which the wall is very thin. So we can see actually, well, I play the guitar. So I've got the tap from my neighbor. So somebody, Ejiri and Sakuragi was enough about that. So he invented the automatic tap back machine, which we call kabe-dan machines, or those kind of things. So every year in the winter semester, I love to see our students, undergraduate students, invention with existing electronic devices and sensors. What we do is more. We enter into the device itself. That is our research. The goal of Aspire Mondial is solving the world problem. Yes, through device innovation, we invent new devices in order to solve our problem in this world. So innovation in edge devices can be integrated sensors, actuators with electronic circuits. So our research scheme is really unique or very different from the ordinary style of the research scheme. So our research is diversification by nature. So now, quite often, cutting-edge research, top research, refers to digging type research, according to me. So this is a research field here, you can see. So many researchers are here. They dig very deeply and very narrow, deep things to find one truth. That is very beautiful, yes. Mine is also beautiful, yes. So our research scheme is widespread type research. So many pairs of Aspire, of course, groups looks into very large area. Yes, I found my treasure, something new. Yes. Or here, there is a treasure box. Yes, I open it. Sometimes there is a very big surprise. So this is also very good because what you realize is not what you dream, but what you have done. Yes, that is very important for young generation to know by themselves that what you do must be aligned with what you dream. Yes, but it is only done by experience. Yes, this is my personal experience as well. So collaboration scheme, again, Aspire is a young brain circulation grant. I myself am young as well. I work hardly in the clean room and I write by myself of my experience, but as a first author as well. Anyway, so I would like that many participants will do that. Yes. Of course, research grants should be obtained by each entity or should have been already. Yes. So, of course, I hope that joint acquisition of many grants will be made, including Horizon Europe. Yes. I have many partners. So I understand that this is a large umbrella. As my group is diversification, yes, expressing goodwill to collaborate. I'm happy to introduce later. Yes, real collaboration. Yes, MOU-based collaboration. In short future, joint grants such as Horizon. In mid future, university level MOUs. In long future, I hope that there will be joint laboratory such as LIMS, CNRS, Tokyo University of Tokyo Institute of Industrial Science. Yes, LIMS is the first CNRS laboratory outside France. The first laboratory for VIP visit in Japan, actually. So this is the 1st of April. So I shake hand with the President de République like this. So I hope that in future, my laboratory, Nanosystem Integration Center, will be something like this. Yes. So philosophy is important. Open target research and closed industrialization. I set a very far end target for ideal integrated MEMS device. So we develop technologies and devices in a collaborative manner. Deliverable top quality devices and processes we co-publish. Deliverable to industrialization based on the developed results. So many advantages. No conflict of interest because the target is very far. Can promote young imagination. Hey, I can do something new. That is the most important thing. Yes, for students and researchers. And it makes me so young as well. Spontaneous community creation that I'm hoping. On the same time, I take full importance on the platform, the place to be realized, like Fab Lab. So I'm the leader of the world top quality super clean room, and cutting edge machines and know-how will be used, and we accumulate the information. So, and hopefully there will be some standard process and open facility. Yes. So this is the one of the integrated edge device. So they have so many good things: intelligence, smell, propulsion, power source, soft body. Those kind of things may be realized through our cutting edge technologies and CMOS LSI technologies that will be made by ourselves. And then we show, hey, we can do something like this. Would you like to collaborate with us? Yes, of course. Let's make industrial one. So that's one of the reasons why I have an IMEC with partners. Yes. So open target is edge semiconductor research is autonomous distributed chiplet cubes. So that is actually, these are the LSIs. So I'm a semiconductor guys. So I would like to integrate all of them: sensing, actuation, processors, communication, powering, and these can be placed one after another and automatically these chiplet tube can communicate and understand what it is. Yes. But indeed, yes, this is my long-term and never-ending PhD work, actually. So I joined in Professor Hiroyuki Fujita's laboratory, the top guy of the MEMS, the reference guy. Yes. I dreamed something MEMS strong one. So like this diamond guy, bam, 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 bam. Yes. But as soon as I started to make my MEMS device by myself, I was disappointed because they were not super something board like this. Yes, you may imagine who is this. So due to some yes, so I wrote by myself. So some small ones, yes, MEMS is really rather like this. Yes, only limited functionality. So I started my research by disappointment. But then I changed my mind. Yeah, but small individuals can make beautiful works if we can harmonize individual operations like orchestra. Indeed, as early as 90s, our group made a nice presentation of collaborative work. Mr. Ataka made a collaborative serially motion actuators. In Japan, there is a school festival. So big ball is sent by collaborative work of this elementary school student. And look at this. This guy they're doing nothing like me. But we don't care. We have so many things, so many others. This is one of the starting point. Harmonized numbers produce great power. Micro electro autonomous distributed system. I wanted to realize something like this. Yes. So I was sent by Professor Fujita for 1 year in Lille city in France at the UMN CNRS to the Professor André stage as a test project of Miroir du Linsa. So I, yes, invented smart maps. MEMS conveyance system was shape recognition. Yes, Yoshio-mita, yes, who is very nice looking guy, very young one. Well, so what I did was I created some processors, micro actuators, and sensors, which automatically recognizes in a distributed manner what is the shape of that you are handling with. Then, after knowing that, we can push that object to the desired direction by collaborative work of tiny entity. So this is the starting point, actually. And so many things has been passed. And I had a couple of very good collaborations thanks to the JSPS CNRS bilateral project. The code name of the 2018 was Paris, Parallel Integrated Microsystems. Yes, so the target has been Chlamydomonas lianghardi, which is a microalgae for alternative energy. So microalgae energies. What they wanted to do is to know if he is fat or not. Yes, so metabolic system. Yes, how do we do that? We turn them, turning. Yes, so but simply turning is not harmful to the algae. So we can make them live. So non-invasive measurement can be made. So by changing the introductory the rotational field and changing the frequency from low to high, from 10K to 1 gigahertz, yes, hopefully. So we can see some kind of spectroscopy, what we call body diagram. And this contains a very useful information on the microalgae application, but they had so many problems. So this is a turning. Or defocusing is made because, yes, they had only a shallow electrode. So it levitates up. Clearly, we had to do something. So many intensive back and forth, the visiting has been made. And we have finally concluded that, hey, we need a millefeuille. So the sandwiched electrode structure in order to push the naturally push that microalgae to the center of the system. So the Mr. Tsuchiya and Okamoto, the very excellent Japanese student, made a very nice system and made a very nice demonstration in a very short time. So I have so many successful collaborative work examples, and with Aspire, I would like to spread out mondial, so the worldwide. Luckily enough, I have so many Japanese students from B4 to D2, D3, actually. Oh, D3 is missing in the photo, but, and also I have an internship student continuously from France, yes. So, and I have a platform. So the world's best platform with engineers. We can make MEMS devices in one day. Yes, indeed. Because we know by ourselves all the machines. And more, we are VDEC, VLSI Design and Education Cooperation Scheme. This is a broker system for the Japanese universities or 2D LSI. So we have continuously LSI fabrication, and this LSI can be a very good target for the as a basement of our microsystem. Something like this one is another completely different, like many treasures. And one of the treasures that I am showing is photovoltaic of 60 volt, 60. By nature, it is impossible. So there is a band gap of 1.1 volt for silicon, but we have circuit technology and fabrication technology. Yes, likewise, we go beyond the physical limit of the materials. That is our group. And also we are MEMS guys. We are, some of the students, Japanese student and Indian student, made a zero power maximum shock sensors. To tell the truth, our shock sensor is turning around the sun, whereas our dispatch payload launched by Hayabusa with Hayabusa 2 or something like that. That technology was really employed for new computational machine like Ising machine. So I have no time to get into the Ising machine, but we have so many nice examples towards the new computational true electromechanical computing. Yes. So these are the partners. Bio and mechanical engineering professors is my partner, as well as Hiroshima University, LSI designer, KU Leuven, University of Glasgow, IMEC, Minnesota, and CNR's engineering, 119 laboratories are there. Yes. And in the end, I hope that there will be a very close collaboration, dense collaborations. Yes. So dedicated function will be integrated via chiplet, work package 1, 2, 3, 4, electro-optical communication, electromechanical sensors, electromechanical computing chips, and more chips. So we can include everything. Yes. So this is my center, NanoHub, school level, one-stop research hub, which is collaborative research hub over the fabrication technology layer, the top clean room in the world, based on the infrastructure. So we would like to make a category 1, communication, 2, cohabitation, 3, collaboration. So the activities, so many activities has been already made. So I am very, very happy to make a kickoff boot camp on the March, and high quality lectures and discussion has been made. Yes, so the next rendezvous will be in Paris, Open Symposium in 3 to 5 June 2026, combined with DTIP conference. Yes. So this is the end of my talk. Let us know your dream. We can collaborate all together to realize our dreams. Thank you very much.
Thank you very much for the very detailed and inspiring presentation. I would like to welcome in the webinar 2 respondents, Shuri Takeda, who is Chief at the Aspire Office, Department of International Affairs at JST, and Emmanuel Chauvin, Policy Officer for STI Cooperation with Japan, Directorate General, Research and Innovation with the European Commission. They will also join the Q&A, so you may also like to address your queries to them. So let's start with the very first question. Eligible partner countries for Aspire. It was mentioned an EU member state may be eligible for Aspire Call 2026 if partner is already funded by the EU, such as Horizon Europe. Does it mean that an EU member state may be ineligible if funded by a national domestic funding agency instead of the EU?
Researchers from EU member states are not included among the 21 countries of Aspire and cannot participate as partners unless they receive funding from the EU. And funding from domestic institutions alone does not meet the requirements of Aspire.
Thank you very much. Is it possible for a Japanese researcher who is directly receiving funding under Horizon Europe to apply to Aspire for a same or similar project? I would like to understand the relationship between Horizon Europe and Aspire after Japan's association to Horizon Europe.
Okay, let me answer. Simply, yes. As shown in my slide, the first slide, Aspire, although it is the international joint research program, it focuses on talent mobility. It can be coexisted with the Horizon Europe research intense Horizon Europe. That's the answer.
Great, thank you. The next question is again to JST. Are certain Japanese universities better aligned for Horizon Europe and Japan cooperation? I heard that the Japanese government had introduced a select group of preferential partners. Thank you.
I'm a JST staff, so I'm not in a position to speak on behalf of the government. But to my knowledge, I have no information about any priority among the universities in Japan to apply to Horizon Europe.
That is
Thank
correct.
you so much.
And on behalf of University of Tokyo, I should say that University of Tokyo is a very good university. Thank you.
That is true.
And NIMS is also a very good institute, by the way.
Thank you. Thank you
That
very
is
much.
Okay, the next query, again to JST. Thank you very much for the presentations. My question is for Kawashima-san. Is it possible to use the Aspire Fund to support students from the Counterpart Institute in coming to Japan? Let's have a look. So it probably means a European institute, if I understand it well. Students
yes.
who come from Europe to Japan.
Yes, it is possible. Because the program is designed to promote the mobility between Japan and the counterpart countries. So we are welcome to invite researchers from partner countries to Japan and conduct research. So it is possible to use Aspire Fund to support such kind of mobility activity.
Thank you very much. The next question goes to Tom Kuczynski, but Emmanuel Chavon might also like to answer. Japanese institutions can get funding in Pillar 2, but is it correct to say that they can still apply for programs in any pillar? They would just have to bring their own funding.
So basically, a short answer is yes. So with regards to institutions, of course, it'll be better even to know which scheme that person is thinking about. Because if it's doctoral networks or staff exchanges in Pillar 2, or research infrastructure also in Pillar 2, in Pillar 1, this indeed would require to secure budget. Also, if this is SME, for instance, it could in principle benefit from grants under Pillar 3 if that SME would be willing to relocate to Europe. So in principle, yes. And of course, just the tangent for other schemes, mono-beneficiary schemes under Pillar 2, so Marie Skolsky reactions or European research grants, of course, successful applicants are fully covered by those grants. Hope this answered the question. Thank you.
Thank you so much. The next question is again to Tsuchiya Sensei. Wonderful presentation. How long is the student expected to stay? Also, how was the host institution decided? Was it based on the student's own preference, or was it arranged through matching between the PIs?
Okay, thank you. Actually, for the students, basically, our students stays 3 months. It is because we need to do a lengthy visa procedure. So first step, actually, I recommend 3 months for the students. And how was this host? Yeah, this actually for at the time of applications, my students know some of the European PI. So actually, I asked them to who you prefer. Then actually, most of the students decided who they already know. So actually, so far, it was decided by the students' own preferences. But after the first kickoff meeting, actually, my students now all know all of the PIs. So they are now talking about second or third outgoing. Yeah. So maybe this can be maybe strongly depend on the how we have meet each other in this Aspire project. Yes.
Thank you.
Okay.
Thank you.
In my understanding, the JST's the preference is the longer is better. 1 year.
Yes. So regarding students, basically, I recommend first 3 months. But for postdoc researcher or tenure track, actually, I recommend 1 year. And actually, one of a tenure track researcher is already decided to spend 1 year in this Aspire project. Yes.
I have sent my student 1 year, so which is very good. Now they're making some kind of 6 months to staggered to sending program and accepting program. And I hope that the guy sent to Europe will bring somebody back with him or her. Yes. Thank you.
Thank you very much.
Thank you for the clarification. The next question is addressed to either Emanuele Chauvin or Tom Kuczynski. Thank you for your introduction. I would like to clarify whether the UK is considered part of the EU in this context, as collaboration with partners based in the European Union appears to be required for the application. In addition, regarding the health section, may I confirm whether the application period for this year has already closed? Does this mean the next opportunities would be in February and June 2027? Just to be sure, there will be no additional call in June this year. Is that correct? Frankly, I'm not really sure which program the question.
Sorry, the UK is mentioned at the beginning in the first sentence?
Yes.
Yeah, for forthcoming calls, it's simply we would encourage to look into the EU funding and tenders portal. Most of calls are already published for 2026. Most of them, they are open already for submission. And it could be useful in specific area like in health. So they'll be in cluster 1 to find a work program for this cluster and look basically into the list of topics. It may be, in fact, that some calls will be still open this year or late 26. I'm not sure about that. Once again, I would encourage to look into the EU funding and tenders portal.
That portal is very
for
useful.
the UK, no, UK is not a part of the EU.
Just in case the question referred to the Aspire, the UK is one of the partner countries of the Aspire. So if you are based in UK, you are eligible to apply. And if the health section in your question, if it referred to the Aspire run by AMED, I am not sure about the application period and schedule of the next call. So I recommend you to go to the AMED website. Sorry, Emmanuel.
No, yeah, I just wanted to complement what Tom said and recall the consortium composition rules for Horizon Europe. You have to have one participant from a member state and then two other participants that can either be from a member state or an associated country. So as UK is an associated country, so you can have a partner from UK in your consortium, but you would have the need to secure another partner from a member state. And for the open calls related to health, as Tom said, all the calls are published on the funding and tenders portal, and you have filters to know what are the ones that are already closed, what are the ones that are currently open, or the ones that are planned and will open soon. So I would invite you to play with those filters to really see if there are more calls to be open this year or that are still ongoing, because it is possible indeed that few ones are already closed in the cluster one, but there may be more coming later this year. And we will have an amendment of the work program with additional calls later this year. But I am not sure they concern health in particular, but you could also have a look. I would regular look once the amendment has been adopted. I would advise you to keep an eye on it.
Thank you for all the additional information. I hope that answered your query. And the next one goes to Professors Tsuchiya and Bisquet. Thank you for showcasing your successful brain circulation case study. I'm wondering if you could give advice on how to choose team members from multiple countries to form a strong network under Aspire to create a synergy instead of competition within the group working in overlapping spaces.
Okay, thank you. Maybe I will talk first. Okay. In our Aspire project, I deliberately choose the researchers with a completely different expertise with me. So about the expertise, I think almost no overlapping. So for the meeting, we have we can when we discuss each other, we can find something new each other. So yes, so I don't feel any competition in this Aspire project, but I feel quite a synergistic effect each other during the work. Yes, and also for the choosing the researchers, I'm quite taking care of the passion to work with young researchers and students. Yes, I think this is very important because most of the purpose for this project is fostering the young researchers. So if some PI is not does not like to work with the young researchers, it is not this project cannot be successful. So at least in my Aspire project, all of the PIs are quite loving to work with young researchers. So yes, that's a very strong, very clear criteria for me.
Thank you.
And do you have comment, Juan? Additional comments?
I
No?
think you were very smart making the consortium, no? Because you mix like old people like me with a lot of experience, and so on, younger people, which is more pushing. So the goal is make a diverse consortium, but also very dynamic, so that the project will work well, so that everybody will contribute to the project, believe in it, and yes, because sometimes managing projects with consortium is not so easy if there's a diverse, but we had this meeting and it's clear that you were very successful picking the people because actually you inspire the people to work on the project, exchange. And exchange is not so easy. You have a very bright student, you have to send to Japan for some months. Each time it's not clear as going to do papers. But in the end, it's all very beautiful because we'll acquire new knowledge. So yeah, I think it's a very good strategy to make the project what you have done. Yeah.
Thanks.
Thank you. Thank you so much. The next two questions go to Emanuele Chavon and Tom Kocinski. You mentioned that almost all Pillar 2 grants are available to Japanese researchers. Could you please tell me where we can see the list of non-eligible grant types? And the second question is related to that. What programs outside Pillar 2 are Japanese researchers able to join as beneficiaries?
Manuel, would you like to take it, or shall I reply?
I can take it if you want. As for possible restrictions, they are always very clearly stated in the eligibility criteria of each topic. So I would really invite you to carefully read those because there are some topics that are restricted for, I would say, security and strategic to protect the strategic interests of the EU, but most of them, really the vast majority, are open to associated countries by default, and for a few of them there is an additional layer of restriction where we ensure that the associated country have sufficient safeguards in place, and it really concerns a very small number of topics, and in those cases the countries who have given those reassurance and who are eligible are clearly stated in the eligibility criteria text of the topic. And what was the second question? Yeah, for other possibility to participate as a beneficiary, there are options in Pillar 1. I'm thinking of the MSCA actions and ERC grants as in the synergy grants. There are possibility for Japanese researchers to be funded and receive as beneficiaries in the program. And also, as Tom mentioned earlier, in Pillar 3, some SMEs, Japanese SMEs, could receive support and funding from the EIC, European Innovation Council, should they relocate in the EU. So there are possibilities outside of Pillar 2, yes.
Thank you.
Just maybe to complement on this restricted calls. I'm not aware of any list which is publicly available. Once again, this is just a handful of calls. There are, in particular, there are some in Cluster 4. So this is on digital industry and space. And I tried to locate some of them, and basically I couldn't find even in a funding portal right now. This eligibility is mentioned in additional documents. So always for each call, you can check this tag, and in some of them there may be this particle provision. Thank you.
Thank you. The next question is very much connected to this topic. When will Japan and the EU sign the agreement?
For this, I can take this one as well, maybe, because I would like to apologize for not joining this seminar from the beginning. I was actually discussing with the member states on this agreement to ensure that we can sign as soon as possible. So all is going in the right direction, and so from the conclusion of negotiation, which happened at the end of last year as a Christmas gift for all of us, it takes time. The administrative procedure takes time on both sides, and especially on the EU side, because we have 27 member states. So it takes a little bit of time to have a full adoption of the agreements, and we should be ready for signing after around mid-June. So I think we will have the signing happening before the summer break. I cannot say any exact date because, of course, this timeline is always not fully confirmed, and then we need to find a proper date for the signing to ensure we have the right person around the table to hold the pen, but it should happen before the summer break, the EU summer break, so before, so in June, July, something like that. But it should not prevent you from applying already.
Indeed, indeed. So the exciting moment is to come, but the applications are open.
Exactly.
Thank you. The next question goes to Yoshimita, professor for a university with niche expertise. What's the most effective way to signal this value to fitting Japanese partners for collaboration?
I understand that this question is from EU or European partners. Yes.
Most likely.
The best thing is please publish and come with publication. Yes, that is very good thing. Yeah, I have a very good collaboration in very niche technology, electroplating, with a CNRS laboratory in Toulouse. So I met in some meeting, Japan National sur la technologie émergente. So so he called me, hello, professor. I am a specialist of electroplating. Yes, this is very good. Those kind of things. Yes. So again, publish what you have done, and then try to communicate. So that is the very good way to do. So, and that is the way that we are doing as well. Thank you.
Thank you. The next question is also addressed to you. Is it possible to start bilateral collaboration with you, or do you prefer mondial collaboration with several groups involved worldwide?
Bilateral project is the best one, and mondial can be used as a security insurance and catalyzer actually. So, and I actually always ask my partners to submit something inspired by mondial, and some of our colleagues are already successful in getting their grant as well. So this is the way to do that. And if you are interested in, don't hesitate to contact Judith to be connected with me. Yeah, thank you.
Thank you for the response. And the next query is addressed to Emanuele Chevon and Tom Kuczynski. Usually, the normal life of a professor in Japan is fairly busy. I guess that's true in every country. Without any help, most people will not have time to even apply to Aspire or other projects such as Horizon Europe. On the other hand, EU-related applications usually involve large amount of paperwork. Are there any means to provide actual help to Japanese researchers willing to apply? For example, dispatching a helpful officer, even in the form of online meeting, or helping to navigate through the necessary procedures and templates and working together towards submitting the application.
Here, I would like to stress that we understand, of course, that the whole process is quite complicated and time consuming. This is why the Commission is really working hard on simplifying the application procedure for the applicants. If you have ever already tried to apply to Horizon Europe and you are trying again, you will see that the forms have been simplified and the proposal now is shorter. We also put in place novelties that we will enlarge with the two-stage proposal, where you first have to propose a very, I would say, short summary of your proposal, and should you be pre-selected, then you can, expand and prepare the full proposal to avoid too much work ahead. And if you look for advice and guidance, there are a lot of resources on the portal with practical guidance sessions that have been recorded that are getting in very much details. So I would invite you to look at those. You have sometimes online that are organized where you can directly ask your questions. We have a help desk on the funding portal that is very responsive and can reply to your queries very quickly. And also there are national contact points in Japan who are here to help you, and they can provide you as well help in Japanese if navigating the Commission English EU institution English is sometimes not that easy. So you can also request the support from your national contact point.
Indeed.
Just maybe to complement, it depends also of this professor, whether he's interested in collaborative research or maybe a ERC grant. Many universities in Japan and also research institutes, they have sometimes quite expanded team of research administrators who are more and more knowledgeable about Horizon Europe, including application procedure. There's a lot of institutional memory as well. So please don't be discouraged by complexity of the program, because there are already others before you who tried, and there may be also support in your own institution. So please explore those. And for NCPs, we also expect that the association will translate also into expanding national contact points in Japan, whether it will be for general inquiries or specializing in specific priority areas for Japan. This is to be seen. Thank you.
Thank you so much. With that,
in my personal experience, it is a more consortium in Europe who already appointed some company to make a management. So this is the normal way of Horizon to the very big grant application. So probably it is the partner of the European side who knows better than us Japanese. That is my understanding. Thank you.
Thank you very much, Professor. This is a very important point, because the vast majority of work and responsibility in consortium-driven projects lies on the coordinator. But then, of course, there are schemes for individual researchers, and then again, then collaboration with host institution in Europe would be essential. But if we are talking about collaborative research, and Japanese entity is a partner, then vast majority of work, once again, is in hands of the coordinator. Thank you.
Thank you for all the extensive answers. And with that, we have reached the final query. Are Aspire proposals, this is for the JST colleagues, are Aspire proposals submitted only by Japanese researchers? I assume applications are required to be written mainly in Japanese.
Applicants for the Japan cycle, now open, must be researchers affiliated with a Japanese institution. Applications must mainly be submitted in Japanese. For joint codes, both the Japanese and partner side researcher may apply, and the application form varies depending on the specific code. Please check the code text. Thank you.
Thank you very much. We have reached the end of our webinar. I would like to thank our esteemed speakers to have contributed to this event. We still have lots of attendees. Thank you for being with us for so long. Please follow us on SNS. We are looking forward to seeing you in upcoming webinars. And a special thanks to all the colleagues who have co-organized this event. I'm looking forward to working with you in the future as well. Thank you and goodbye.
Thank you very much.
Thank you.
Thank you.
Bye.
Thank you very much.